Okay, so I'm going to help do a couple of the ones from this grid for you. The key idea is kind of like it shows on the pictures there, where if sodium wants to lose one electron, right, that electron can't just go away, right? It has to go somewhere, so it's going to go to an anion that's going to gain it. So if sodium wants to lose one electron, oxygen wants to gain 2 electrons. That's not quite a match made in heaven, right? But instead of saying, well, they just can't react. Well, they can, but we're going to have to balance that a little bit, right? So we can see over here. So if we imagine a teeter-totter, right? If I have a +1 and a -2, that's not balanced out, right? We need it to add up to 0. However many total electrons the sodiums lose, all the oxygens need to gain those. So if I see a +1 and a -2, well, if I have a second +1, now that balances out, right? Now those two add up to 0. So I need 2 sodiums for my oxygen. So the way we show that is we just write Na, and then we write a 2 down low and an O. Na2O, sodium oxide, right? So we look at the next one. That's a +2 and a -2. Well, that's already works really well. Calcium wants to lose 2 electrons. Oxygen wants to gain 2 electrons. So we just need one of each, CaO. Right. On the other hand, if we look at something like calcium and nitrate, right? Nitrate's one of those polyatomics. Those are on the back of your periodic chart, right? So if we find nitrate, that whole group together, right? NO3 is nitrate. It's got a -1 charge. So the thing is nitrate. So I have a +2 and a -1. So it's kind of the flip-flop over here of what we had before. So I have a +2 and a -1. Well, now what I need more of is the minus. Right, so I'm going to get a second -1, and now that balances out again. So in order to show 2 of these, now we're going to have to kind of do like a math class where we put parentheses. So I'll do Ca, and then the thing is NO3, and there are 2 of those. Right, this shows that there's 2 of the nitrates. So 2 nitrogens and 6 oxygens, but it's 2 nitrates altogether. So if you need multiples, you put parentheses. Now here with a +1 and a -1, I wouldn't have to worry about that. I could just do NaNO3 like that, right? You'll notice there's a couple vanadiums on there, right? Vanadium's a transition metal. It's named after the Greek goddess Vandus, who is a goddess of beauty and charm, because it can actually do a lot of different colors, a lot of different charges. So it can be +2, +3, +5. I was thinking there were a couple others too. But then also who it bonds to changes the colors that it makes a lot. So it's a really pretty element. It can get multiple charges. So where we did the ions here, like everybody in column 1 gets a +1 charge. These ones in the middle are a little more complicated. So they can do some weird things with rearranging their electrons. Not what we're going to have to worry about. We'll just need to know that some of them can get more than 1 charge. So if I do a +3 and a -2, good idea to pause me and see if you can get to where you would need to be on that. Think least common multiples on that. All right, but if I've got a +3 and a -2, well, I need more on the -2 side. So that's -4. So that's actually too much minus now. So then we go back. +3. So that's +6. But this is still only -4. So now we go -2 again. And hey, look at that. That's a -6. So those add up to 0 now. So I'm going to need 2 of the +3s to get to +6, and 3 of the -2s to get to -6, right? Which that's just least common multiples, right? Least common multiple of 2 and 3 is 6. So it takes 2 of these and 3 of these. Same thing with the V +5 and the O -2. That's another one's going to be a little bit complicated. Maybe pause me and try and work ahead there. Least common multiple is 10. So it's going to take 2 of these and 5 of these. One little trick you can do is a lot of people call it crisscross. My high school teacher called it the whip it method, where you just whip it across. Right. Well, I'm going to whip the 5 over here and the 2 over here. I'm not going to bring the negative. It's just basically a cheater's way to do least common multiples, right? So it's V2O5. V2O5. 2 + 5s get you to 10. 5 - 2s get you to -10. That adds up to 0, right? So do the rest of those on that. Remember parentheses if you need multiples of one of these polyatomic ions.